Hi everyone. So today I will be explaining more about the Dijkstra algorithm. So as you can see here, this is an example of a graph with the length. I will skip to the last part. As you can see, here is the shortest length from A point to H. I'll explain it from the start. So the A on this side is the vertex that we are considering, and this side of the vertex is for this one is from, and this one is to. So from A to vertex A would be 0 length because it does not have length from this vertex A. And then from vertex A to vertex B is 8. The vertex from A to vertex C, as we can see here, is 2. A to D is 5. And then here we can see from E to H, they do not directly link with vertex A. The vertex A only link to vertex B, D, and C. From here, the box number is the shortest length, which is from A to vertex A. After that, from this option, from A to vertex C, the length of vertex A to C is the smallest. So we will box it, drag it to the next row, which is the vertex C we are considering. We drag it all down the number of 8 to, because the number, the sum here is 0. So we drag it down, and we now considering the vertex C from vertex C. So we can see here the vertex that is directly linked to the vertex C is D and E. Since we are not using B because it is not directly linked, we will only drag the B, the length from A to B, drag it down to the next column. So to get the 4 and 7, we look at point C. We consider the length D. So from from vertex A to C and to D would be 4. This one 2 plus 2. The equal is 4. To E, we are counting from the length from A to C and then C to E. So the total is 7. From this option, the shortest length after the length of vertex A to C is vertex C to D. So we drag it down and then box it, and then we will consider from the vertex D now. As you can see, the number under the vertex B when we are considering the D is 6. 6 because if we count from A to C and then to D and then the vertex B, the length will be total to 6. Now we look at vertex D to E. The length is 5 because we count from length A to C and then C to D and then D to E. So the total will be 5. We look at vertex F. As we can see, the vertex D also directly linked to F and G. So there is number for vertex F and G when we consider the vertex D from vertex D. So from the length from vertex A to C, C to D, and D to F would be 10 because the length A to C is 2 plus with C to D, that is 2, and then D to F, that is 6. So the total will be 10. And then we look at vertex G, D to G. We come from the length A to C, C to D, and D to G. So the total will be 7. From this option, we do not count the box number because they are already considered. The smallest length from A to go to the next vertex is vertex E, that is the length 5. So we will drag it down again and then box it. So we will repeat it until we reach H. That is our goal. And then we count it until we have the shortest length to reach from vertex A to vertex H. Notice that there are finite sign. That is because it is not directly linked to the vertex that we are considering. So we will only put the sign infinite. So the shortest length will be starting from vertex A and then C and then to vertex D and then to vertex E and then to vertex G I'm sorry, it is, oh yeah, vertex D to vertex E and then to vertex G, vertex D to vertex E to vertex G and then vertex F and finally vertex H. It will result in the total length will be the smallest or the shortest length that we can have from the vertex A to vertex H.